Good afternoon, my name is Rich Kenny. I'm the IT Director at Techbuyer. This is my colleague, Nour, who's the KTP Associate at the University of East London. Nour specialises in software engineering and machine learning. At Techbuyer we specialise in network storage and servers, and specifically optimal server configuration, which is what this tool is kind of based on. So we're presenting the start of our 2-year research project into creating a data center energy efficiency modeling tool, or DCEM. The reason we're targeting hardware is it's the single largest user of energy in the data center, and it's where we can make a significant impact quite early on with optimal configuration. So what we have is a 3-step process. Step 1, you'll input your current server configurations alongside your environmental conditions for your data center and the infrastructure. That will then give you an accurate estimate on energy consumption, PUE, CO2 emissions, and also your energy efficiency scores for your current hardware configurations. Step 3 then will give you the optimal configurations based on either your current kit or refreshing kit, or basically changing any form of hardware that you've currently got, and that will tell you the energy efficiency rating of that equipment and therefore potential savings on costs, CO2 emissions and environmental outputs. So Nour's going to take over and tell you a little bit about the tool we've created and what we're working on at the moment.
Thanks, Rich. So I'll brief you into the methodology we are following to benchmark our servers. We are using the server efficiency rating tool developed by SPEC, a leading organization in benchmarking. And the tool is currently adopted by the US Environmental Protection Agency for their Energy Star labels for servers. The tool is balanced in a way that it gives the efficiency scores for 3 workloads, which are the CPU, storage, and memory. And each workload is composed of a set of transactions that stress a particular function of the server. For example, the CPU workload has 7 tests. Each test is executed across different load intervals ranging from 10% to 100% utilization. One of the tests, called compress, basically sends data over to the server we're testing, tries to compress the data, uncompress it, and measures the number of transactions, the elapsed time, and the power consumed during this whole process. At the end of the test, we get a balanced overall efficiency score, and which is basically transactions per second per watt, and we also get an overall performance score for the server, which is transactions per second. We will be running these experiments across hundreds of different servers with different manufacturers, different RAM and storage configurations, and even different CPU specs. So at the end, we would acquire a comprehensive data set where we can apply machine learning, mathematical modeling to predict any server configuration in your data center. So we give you a very high, accurate estimate of your server efficiencies, and we would also tell you how to improve upon your hardware configuration and to improve your overall server efficiency score. I'll leave it to Rich now so we can show you our initial findings so far.
So we're about 5 months into the 2-year project. We've currently done hundreds of hours of configuration benchmarking. We're actually almost approaching 1,000 hours worth of benchmarking. We've started off by targeting the most well-used servers in most on-prem, off-prem, and hyperscale data centers. So we're basically basing this on N and N-1 configurations and generations. So we'll call them Gen 9 and Gen 10 for ESA right now. What we've seen is in previous generations, the increase in energy efficiency of moving from an old generation server to a newer generation server has been significant. So in some cases, 150% better moving to the latest generation. But as time's gone on, we're nearing a point of almost complete parity. So the move from Gen 9 to Gen 10 was a 10% increase. That could be easily attained by small changes in configuration. So what the graph's showing here is fundamentally that a tiny change in configuration, in this case adding 32 gig of RAM, will actually allow a previous generation server to outperform the current iteration, and these are brand new servers with just minor configuration changes. What we're hoping to help companies do is identify where they can make these configuration changes and have a significant impact. So we're at the 6th generation data center currently showing this benchmarking live. So you can come over there and meet us and talk to us about the research we've done currently. And we've also got some USBs to hand out with our research on it at the moment, so you can take that away and pick it apart if you like. That's pretty much where we're up to the moment. It's quite exciting because it's just providing a series of information to make better decisions about your current hardware refresh rates, whether or not you want to tie into existing OEMs or explore different manufacturers, whether you want to do component level upgrades yourself. It allows you a lot more flexibility in how you manage your whole estate, and the positive effect of that is a significant reduction in energy consumption and a massive decrease in your CO2 emissions, and that's what we're targeting is better environmental efficiencies and fundamentally cost savings for you as a business. So fundamentally better efficiency if you configure stuff properly. That's where we're at. Optimizing refresh cycles, reduction in infrastructure cost, reducing environmental waste emissions, and ensuring proper configurations to make sure that you're making the best of your hardware. That's where we're at. Thank you very much for your time, guys. I appreciate it.